Hi ladies, today we will be working on how to use and express measurements. So a measurement is a quantity that has both a number and a unit. So for example, if you were to say that you were 5'7", that could be 5'7" kilometers or 507 cells. You don't have any unit. So the unit is really important, and it is going to be a requirement for all labs thus far, or from here on out. So in chemistry, we often find that we have really big and really small numbers. So we have to put them in something called scientific notation. All that is a given number is written as a product of a number and something that is a base 10 number raised to a power. So for example, if you had this gigantic number right here, it'd be really difficult to write a paper using that number all the time. So we can write it as its coefficient times a 10 to the power. Now to determine that number, we simply have to move the decimal point to the left or to the right. So when you are moving from the left or the right, we can determine the exponent. So in our example here, we have the number 6,300,000. So if we wanted to move that number 6,300,000 into something that we understand, all we have to do is take the decimal point that's at the end and count how many times it takes until we get a specific number where we have one number in the front and the rest are decimals. So from this number, this huge number, we can take it and truncate it down to 6.3 times 10, and then we will count how many times that decimal point was moved over. So this will be 1, 2, 3, 4, 5, and 6. So our top number would be 6. Okay, let's try another one. Oops, 94700. All right, so we want to get our decimal point between our last two numbers here. So we take it from the very right and we move it all the way to the left until we get to that point. We would end up with the number 9.47 times 10, and now we have to start to count. This decimal point was moved 1, 2, 3, 4 times, so the overall number would be 9.47 times 10 to the fourth. Now something to notice is that you start to lose these zeros. That's okay. They are taken into account for your number in this times 10 to the fourth number. They are not significant, which we'll learn about later. So you are allowed to drop them off of the answer. Okay, so that is denoted here in the PowerPoint as well, just in case you need to remember. So anytime you are going from this position and starting to move your decimal place to the left, that means your exponent will be positive. Now let's look if we need to move our decimal point from the left all the way to the right. So let's try this number. See here, 0.00008. So to get this number into scientific notation, we want to put our decimal point right here after the 8. So if we start here at our starting position, we need to move the decimal point to the right to get our number as 8 times 10. That's always going to be there. Now let's see how many times we moved our decimal place over. 1, 2, 3, 4, 5 times. So our exponent would be to the fifth, but since we are moving to the right, that means our exponent will be negative. If you want to try another one, here is another one. We'll give that a shot. 0.00736. So we need to move our decimal point right to here. Again, you want one number in front of the decimal point after you've converted it, and everything else will be in the will be after the decimal point. So we take our decimal point and we start to move it all the way till we get to the point we need. We write our new number, which is 7.36 times 10. Now, what do we want our exponent to be? 1, 2, 3 times it was moved, so it was moved to the right. That gives us our negative, and the number of times it was moved would be 3. So when you are able to write it in scientific notation, it allows you to write really big or really small numbers very quickly. Okay, so we have the multiplication as well. So whenever you multiply or divide in scientific notation, there are simple tricks to allow you to do it without a calculator. So let's try the first one. Whenever you are multiplying, you will add your exponents and multiply the normal numbers as you normally would. So let's give this one a shot. We have 3 times 10 to the 4th multiplied by 2 times 10 to the 2nd. So during multiplication, you're going to add exponents. So if we were going to add our exponents, 4 plus 2 is 6. So this is our new exponent. And now we're going to multiply our regular numbers, so that would be like our 3 and our 2, like we normally would. So 3 times 2 is 6. We still have times 10, that doesn't change. However, now that we've added our exponents, it'll now be to the 6th. So there's our new number. All right, let's try this one. If you were to multiply 2.1 times 4, you would get 8.4. Now we have to add exponents. So this one is a positive 3 plus negative 7. So if you take 3 minus 7, you're going to get a negative 4. So here's that 8.4 that we got earlier, and our new exponent is to the negative 4th. Whenever you divide, however, you're going to do something different. If you don't have your calculator, you would subtract. So let's give this one a shot. We have 3.0 times 10 to the 5th divided by 6.0 times 10 to the 2nd. All right, so we would divide as you normally would. So that would be our 0.5 that you get in the answer here. So 0.5. And then we're going to subtract our exponents. So 5 minus 2 is 3. So the times 10 does not change. However, our new exponent is to the 3rd. Okay, so in addition and subtraction, the rules are a little different. Whenever you want to add or subtract numbers that are in scientific notation and you're not using your calculator, the exponents must be the same. That's the tricky part. So, for example, when you have 5.4 plus 8 times 10 to the 6th, you have to convert your numbers to have matching exponents. So, for example, when you have 5.4 times 10 to the 3rd plus 8.0 times 10 to the 2nd, these two exponents do not match. So, we can take one of these into a different form of scientific notation. I'm going to pick this one so that our exponents match. Because remember, in addition or subtraction, your exponents match. That's a big deal. So if we wanted to make this times 10 to the 3rd, first I would take it out of scientific notation. So 8.0 times 10 to the 2nd means that I move my decimal to the right twice. So my new number would be 800. Now to get it to this exponent here, you would have to move it to the left 3 times. This is not incorrect scientific notation. That's okay for this problem. As long as within the problem you have something that is not in the correct form of scientific notation, that's okay. But your end result must be. So if I were to add 5.4 plus 0.8, I would get our 6.2 that you see here, and then you add the same exponent at the end that you've had now for all of our numbers. So it would be 6.2 times 10 to the third. So let's try this out with the following questions. Okay, so for the first question, we have 8 times 10 to the negative second times 7 times 10 to the negative fifth. So for multiplication, there we go. For multiplication, you add exponents. So multiply our two numbers like normal. So 8 times 7 is 56 times 10. Now when we add, we need to add our exponents. So negative 2 plus negative 5 equals negative 7. So our new exponent would be 56 times 10 to the negative 7th. Make sure that you have all this work in your notes. It's very important to understand how we determine the number or our exponent number. In our second one, we have 7.1 times 10 to the negative second times 5 times 10 to the negative third. Again, you're doing multiplication, so you must add our exponents. So our first step would be to multiply as we do normally to get to 35.5 times 10. Again, this does not change. And now we add our exponents. So negative 2 plus negative 3 is negative 5, giving us our full answer. And that's also worked out in your notes. So if you need it taken step by step, you have that at your disposal. One thing that I didn't show you is how to make it into correct scientific notation. However, we'll cover that more in depth in class. Okay, here's a nice little guess for you. So you have the scientific notation of 1 mole of water written in scientific notation is 2.99 times 10 to the negative third. So this requires you to move your decimal point a lot. So let's see. Oops. So you have 2.99 times 10 to the negative 23rd. So this will probably go off your screen, but this tells you that to the negative 23rd means that I have to move my decimal 23 times to the left. So 2.99, go ahead and start counting as many times as you can get. So 1, 2, 3, 4, 5, 6, 7. And eventually you will get a number that looks a lot like this. Obviously mine ran off the screen. So scientific notation helps us significantly reduce the amount of zeros in our number that are not significant and allows us to write really small numbers really fast.